So programming is all about control flow. That's all we're doing when we write a program, is we are performing some set of steps based on the input that we get from the user or from previous steps in the program, and taking some actions based on that information. And one of the ways that we control the flow of a program is with conditionals. So programs are actions based on input, whether it's from the user or from a previous step in the program. Conditional statements use Boolean logic to control the program flow. We'll look at the conditional operators, and then we'll look at the conditional statement formats in Ruby. So there's an if-else, there's an unless, there's the lone if, there's an if-else if else, and there's a case when else, and there's something called a ternary. So we'll look at all of those different formats and examples of those, and then we'll look at how we can combine conditions in a conditional statement using Boolean logic. So first of all, at a basic level, a program takes some input, either from the user or another program or further up in this program, and then performs some set of actions based on that input. That's all a program does. So for example, if we have a program that gives advice based on the weather forecast, so this program is going to print bring an umbrella today if it's raining, and otherwise if it's not raining it's going to print enjoy the sunshine today. So what is the input that the program has to check in this example? What's the input that determines what we print? Yes. Yeah, if it's raining. That's the input. Thanks, Jack. Is it raining? That's the input that we're going to check. So what is the action that the program is going to perform based on that input? Yeah, that's right. It is going to print some advice about what to do given that piece of information. All programming languages use Boolean logic to control the flow of a program. That's all they do. In the example that we just looked at, the program has one input, and based on that input, it'll print one of two messages. This is done by a program with a conditional statement, such as an if-else statement. The input is used in the condition. The condition must evaluate to true or false, okay? And the action is the block of code executed when the condition is true. Sometimes when the condition is false. We'll look at examples. So first let's look at some conditional operators. In order to check inputs, programs use conditional operators to compare an input to another value. And then this comparison is going to result in a Boolean value. It'll result in true or false, always in one of those two values. Conditional operations return true when the condition evaluates as true and false when it doesn't. So this first one is equals. For example, 1 equals 1 will return true because 1 does equal 1. All right? Not equals, and the syntax is an exclamation point and an equal sign. That means not equal. So for example, 1 equals 2 will evaluate to false. Not equals, 1 does not equal true. 1 does not equal 2. What will that evaluate to? True, because 1 does not equal 2. And what about 1 does not equal 1? That evaluates to false, because 1 does equal 1. So when we ask the question, 1 does not equal 1, the answer is false. Okay, less than. Less than is an operator that says that the one on the left is less than the one on the right. So if the one on the left is less than the one on the right, then it returns true. So in the case of 0 less than 1, that's true. In the case of 1 less than 0, that's false. Greater than, the one on the left is greater than the one on the right. 1 greater than 0 is true. 1 greater than 2 is false. Less than or equal. So we can use this kind of comparator too. It's true as long as the one on the left is either less than or equal to the one on the right. So 1 less than or equal to 1 is true. 1 less than or equal to 0 is false, because 1's greater than 0. Same thing for greater than or equal to. The one on the left is greater than or equal to the one on the right. So 1 greater than or equal to 1 is true, and 1 greater than or equal to 2 is false. So the thing to notice about these is every one of these conditional operators results in a Boolean, a true or a false. Okay? And that's how we control the flow of a program. It's all this. So we can do that with an if-else statement. That's one way we can do it. So the syntax of an if-else statement is we have an if, an else, and an end. The end indicates the end of the if-else block. Okay? So with the example that we are looking at, first we have the condition. What is the condition we're checking in this example? So you remember the example, if it's raining, print the message, bring an umbrella today. And if it's not raining, print the message, enjoy the sunshine. Right? So what is the condition that we have to check to determine what to print? Yeah. So we're going to check if raining, which we're going to set up as a Boolean variable, if raining equals true. If raining equals true, then we're going to perform an action. What's the action?
Bring an umbrella.
Yeah, bring an umbrella today. Else, the action when it's false, enjoy the sunshine today. Okay, so that's the way that we construct an if-else statement. Is that clear for everybody? Now we can also use unless. I don't like unless because it's counterintuitive to me, but you may find you like unless, and if you do, you're welcome to use it. I've never seen a lot of unless in code that I've looked at. I've never used unless when I write code myself, but the way that unless works is kind of the opposite the way that if works. So it says, unless some condition is true. So here we're going to have the condition again. Unless raining equals true. Okay? So it's really like saying, unless raining equals true, we're going to print what?
Enjoy the sunshine today.
Yeah. Enjoy the sunshine today. And else, we're going to print, bring an umbrella today.
That's
so
like not after the sentence.
Yeah. So my brain does not like this at all. At all. I will confuse myself every time I look at it. Yes?
So using unless instead of if would be the same as using if raining does not equal true.
Yes.
Okay.
Exactly. So for me, it's like double negative. You know, it's like that whole double negative thing, and I don't like it. But, you know, you might like it, and that's okay if you do. Okay, the lone if. So let's talk about the lone if. You can use this alternate syntax when you only want to do an action if some condition is true. So if there's no else case. If there's only an if case and no else, then you can use this. So for example, if all we want to do is print, bring an umbrella if it's raining. That's all we want to do. Then we could use this syntax. Puts bring an umbrella if raining. And you could say if raining equals true. We could have done that in the previous examples. We could have just said if raining, because raining is true or false, as it is. But this syntax where we say action if condition is kind of elegant and readable. So if you don't have any else case, you can write it this way in Ruby. Okay? There's nothing wrong with doing it the other way though. But this saves you some words. You don't have to type the end. If you do it this way, there's no need for an end. When there's more than two conditions, so when a conditional statement considers more than just two conditions, we can use if, else, or we can use a case statement. So we'll look at both examples. So let's say we have a program that gives the birthday greeting sweet 16 if the person's age is 16. It gives the greeting over the hill if the person is over 50. and otherwise it just gives the greeting happy birthday. So there are 3 different conditions we have to check. Okay? If there are more than 2 conditions, we have to use an else if we're going to use an if construct. So what is the input in this case that we're going to consider? What's the input? Age. That's right. The input is age. And what conditions? There are 3 conditions that we're checking, or 2 conditions and an everything else. What are the conditions? Age equals 16 is 1.
If they're under or over 50.
Yeah, age is greater than 50. So greater than 50, not greater than or equal to. Or if age is 50 or less, but not 16, basically, right? So the conditions we're checking are age is 16, age is greater than or equal to 50, and everything else. Oh, did I say greater than or equal to? I said over 50. Let me fix that.
Well, if you're 50, you're over 50. You know what I mean?
Well, yeah, I guess you could say that. You could say that. That's true. Okay, so if we did it with an if, else, the condition, what's the first condition we can check? We can say if age is 16, so age equals 16 is going to return true or false. If what's stored, what's referenced by the variable age is 16, then it'll return true. And we will print, we'll take the action when the age is 16, we'll print sweet 16. Yep. Now what's the condition we want to check else if? What's the second condition? That's right. Let's see if I put it right in here. Nope. Age is greater than 50. And in the case that age is greater than 50, what do we want to print? That's right. And otherwise, everything else is what we put in else. We're going to print happy birthday. Okay? So that's how we would do that with an if, else construct. Is that clear? So we can do the same with a case when else statement. Okay? So this can be a nicer way to do it when we have, especially when we have more, lots of conditions that we're checking. Okay? Sometimes we're checking, 5 or 6 or 10 different conditions, and it becomes cumbersome to have if, else if, else if, else if, else if. It's a little bit nicer to see a case statement, and it's a well-recognized structure in programming. So a case statement, the syntax looks like this. If we have 2 particular specific cases we're checking, we'll have 2 wins, and then we also have an else to catch anything else. So the case, we put the input or we put the input in next to case. So what is our input? What's the input?
Age.
Yeah, that's right. So we just put the input here. We don't put a conditional statement here. Okay, do you see that? We're not saying age equals something. We just put the input we're checking next to case. And then next to the when, we put the first condition. Yes, so if we put the input with the case, then we don't actually put a conditional statement next to the when either. We just put what we're comparing it to. In this case, we're comparing it to 16. Okay, so when age is 16, then we're going to print sweet 16. Now this is where it's a bit tricky. If we have an inequality as a part of our conditional, okay, like we have greater than 50, right? Then we can't, the only way to do that, the way that I've written this case statement, is to use a range. Okay? So I've said 50 to 100. I'm saying, okay, if you're over 100, I won't call you over the hill at this point. We'll just say happy birthday. All right. So this is a limitation of a using a case statement this way. We can't put an inequality here. We're always just putting the value that we're comparing to, but we can use a range. So we'll say over the hill, and every other case we say happy birthday. So we can't use inequalities in a when clause. Instead, we can use a range. If you want to use an inequality, you can put the input in the when clauses directly. So you can do it the way I have it written there. Okay? But I really like using the input in the case statement. It's just a lot nicer. You're not repeating that variable name in each when statement, especially if you have 10 different whens. If you can avoid putting the input in each one of those whens, that's kind of nice. It just reads a little bit better, I think. But you can do what I put here in the box. So you could say case with nothing after it, and then say when conditional statement, when conditional statement. Does that make sense?
So does it have to be range? Is that what you're saying?
Yeah, so if you want something that is like an inequality, where you're checking that it's in some range of things, and you have to use a range if you're going to use the syntax on the left, where you put the input in the case statement itself. Okay, ternary. I call it the ninja conditional only because it looks really impressive when you see it in code. It's a very succinct way to write a conditional, and it's easy to get confused by it until you get used to it. So that's why I call it the ninja conditional, and just also because it gave me an excuse to put that really cute little GitHub icon on the top of the slide. So when you're comparing with exactly two outcomes, so you can't do this with an if, else kind of case, and you can't do it with the lone if kind of case when there's only one. When there are exactly two outcomes based on a condition, you can use a ternary. Okay? So back to our weather message conditional where we have exactly two outcomes, right? It's raining or it's not raining. If it's raining, we print one thing, and if it's not raining, we print another thing. We could use a ternary. And so the syntax for a ternary looks like this. So we start the ternary with the condition, and we don't put if in front of it. So we just put the condition, raining. That condition has to evaluate to true or false. So we could also have written raining equals true here, okay? But it's shorter, more succinct to just write raining, because on its own, raining evaluates to true or false. The point is that whatever goes there has to be a conditional statement, has to evaluate to true or false, okay? Following the conditional statement, following the condition, we put the question mark. That starts the if block. The question mark starts the if block. What follows that is what executes when the condition is true. Okay? Then the colon starts the else block. And what follows that is what executes when the condition is false. Now, in the code blocks, so you use a ternary when your code blocks are really small. A lot of times you use a ternary when the block is only a single word or a single expression. Because we have two words in these blocks, we have to put parentheses around it. Okay? A lot of times you'll see ternaries get used when there's a single expression that's executed in the code block, and always when there are exactly two outcomes. All right? So you don't have to use ternaries, but you do have to know how to recognize them and what they do, because you'll see them in code all over the place. Programmers like to use ternaries when they're appropriate, because it's just a nicer way to write something. So you just have to get used to the syntax, that's all. So let's talk about combining conditions. Sometimes, a lot of times, we want to consider more than one condition in a conditional statement. So far we looked at if it's raining, or if age equals 16 or age is greater than 50. But sometimes you want to look at two separate conditions in a single conditional statement. That's where we're going to use Boolean logic to use and or to look at the combination of these multiple conditional statements. So for example, if it's raining and below 20 degrees, print wear something warm and bring an umbrella today. So what are the two inputs?
Raining and temperature.
Yes, raining and temperature. And when do we want to print the message?
When?
When do we want to print the message? Raining equals true and
Temperature is below 20.
temperature is below 20. So you can hear the and when you describe the problem. When it's raining and temperature is below 20. Okay? So we can use and operators and or operators to combine conditionals. The result will be based on Boolean logic, based on those truth tables that we just looked at. We can combine as many conditions as we like with these operators. So you can combine 4 or 5 or 6 or 10 conditionals if you want. I wouldn't, okay? But you can. There's nothing to stop you from doing that. And the result is going to be based on the Boolean logic for those two operators and or. To create a conditional statement where both conditions must be true, we can either use the ampersand operator. That's one way to specify the and operator. Or in Ruby, we can also just use the word and. Okay? So to create a conditional statement, so we could say, for example, puts wear something warm and bring an umbrella if raining and temperature less than 20. So that's kind of nice because it reads just like the problem statement, doesn't it? To create a conditional statement where either condition must be true, we can either use the double pipe operator, or in Ruby we can also just use the word or. So, for example, if we wanted to say, wear something warm and bring an umbrella, if just one of those conditions is true, then we could say, puts wear something warm and bring an umbrella if raining or temperature's less than 20. But which one of these is correct for a problem statement? So the problem statement, do you remember it?
The first one, we can see how one more.
That's right. That's right. So the first one is correct for the example that we have. If we want to print wear something warm and bring an umbrella if it's raining and the temperature is less than 20, then we would the right code would be the first line there. Okay, so programs take actions based on input. We use Boolean logic to control the flow of a program with conditional statements. Conditions include some input and evaluate to true or false. They always evaluate to true or false, okay? The lone if can be used if there's only one condition to consider, only one outcome. If else, or case when else can be used when there are more than two outcomes. And if our condition is based on more than one condition, we can use the and or operators to combine the conditions. All right, any questions about that?
Those pipe, the double pipe and the double ampersand, that's the more common through different languages that are used.
That's right.
Pretty much that's the standard for most languages.
Every other language, I think, just about, it won't be every other, there will be some languages with some weird ass syntax like Haskell and stuff like that. But yes, so in Ruby, the preference is when you're combining conditionals that you use the words, but nobody's going to get upset with you if you use the double ampersand and double pipe, because yes, every other language, not every other, but almost every other language, that's what you're going to see. Double ampersand and double pipe. Yes, I see. What do you mean? Yes, they are short. Yes, they are short circuiting. Do you want to explain what that means, Isaac?
Pretty much, if you've got a like and else, sorry, lots of ands or ifs. If it equates to a negative, it will just close itself out. Not trying to like others.
That's right. So you can also use it to force code to execute. Okay? So the way that, not just in Ruby, but in a lot of languages, the way that this works when you have multiple conditions that you're combining. Okay? So say, for example, we say raining and temp less than 20 and wind. Yes, I was going to say sick. I'll put sick too. And wind. Okay? So, because in order for this whole thing to evaluate to true, what has to be true? For me to get a true out of this whole, everything has to be true. Okay? So if raining is false, is there any point in evaluating the rest of this?
Yeah.
No. So what Ruby and most programming, I won't say all because I don't know for sure, but I can't imagine that any programming language would operate differently. Ruby will get this far and stop. It won't even read the rest of this. It'll just stop there and say, nope, this whole thing's false. Okay? Now, on the other hand, if these are ors, what has to be true for this to be true?
Just one thing.
Just one thing. And what has to be true for it to be false? All of them have to be false, right? So with or, the first one that I find is true. If that one's true, it stops. It says this one's true, I know the whole thing's true. On the other hand, if this one's false, it'll keep going. It'll have to read every single one of these to be able to make a false determination, right? So the same is true with and in the opposite case. Let's look at that one real quick. So if we have and, in order for it to be true, all of these have to be true. So if this one's true, it has to keep going. This one's true, it has to keep going. This one's true, it has to keep going. It has to evaluate everything to make a true determination. Okay? So when I said you can use this to force it to execute code, if, for example, I want to add two variables and store it in another variable. So if I wanted to say sum equals A plus B and puts sum, if A or B isn't a number, if that isn't a number, then this isn't going to execute and this won't print. Okay? As long as A and B are a number, then this will execute and this will print. So I forced it to do this and actually do a variable assignment, and I'm also checking the result, that the input was valid to print this. So that's what I mean by you can force it to execute.
Then you can add a number bit to that, but if it's not, it returns an error code and prints something different and say, oh, it didn't work because of this reason.
Yeah, so the way you would probably have to do that, because I have this in a conditional, I would probably have to do a try. It's not a try catch in Ruby, it's a rescue. I would probably have to rescue an error and deal with it that way. So we'll talk about that. I think we talk about that next week, so it's not far away. All right. Any other questions? It was a good question. Okay, so if we look in Canvas, what we will work on, this afternoon, we're also this afternoon after lunch, we're going to, everybody's going to fork the morning challenges repo, and we're going to pull down the challenge, the first challenge, and we'll do it together. But that won't take up the whole afternoon. So we'll also have a look at, I think you guys did this one on Wednesday. Did you do data types and variables? Has everybody done that one? Yes? If you haven't, you should do that one. And also, let's look at control structures because it's probably over conditionals and loops. So, yep, so you can do this challenge in the banking app. So some of you may have already done this. If you haven't done this one yet, the banking app, does it make you loop? Let's see. It's just one question, no looping. Okay, so if you haven't done this, this module's challenges, that's what you can work on this afternoon. And yeah, that'll be it. That'll be it in Canvas for the moment. So if you have done that, then just look at your banking apps more, or do stuff in the workbook. So in the workbook, there's stuff on command line, and then there's also a section on Ruby. It'll take you a little while to get through all the command line stuff, so you could probably just focus on that today. There's quite a bit in there. It will get you really comfortable with the command line, which is good when you're a programmer, to be comfortable with the command line.